This is a bonus episode of Away, a podcast for anyone interested in a secular approach to 12-step recovery. I'm your host, Steph Roberts. Hello, everybody. I am recording this on Sunday morning, January 6th, 2019. And today, I actually wanted to read a little bit from and talk a little bit about an article that a friend of mine sent my way, a friend of mine who does not have a problem with alcohol, but who knows that I do. And it's fascinating. It's from The Atlantic. And if you've never read The Atlantic or looked at The Atlantic or don't know what The Atlantic is, it's worth taking a look at their website, reading some of their articles. They cover all kinds of different things. I'll read you a little bit of the history of the magazine. Since 1857, The Atlantic has been challenging assumptions and pursuing the truth. As we reflect on our past and look toward the future in a world where ideologically narrow or simple answers are less adequate and can be even more destructive than ever, we decided to put to words a handful of ideas we thought represented authentic guiding commitments for us and to our audience. Look for the truth above looking for a story. Continue to explore rather than imagining we've arrived. Go beyond what happens to what matters. Embrace a diversity of perspectives. Immerse ourselves and our audience in the world instead of escaping from it. And that is the magazine in which this article appears. And it was written by Ed Young, who's a staff writer at The Atlantic, and he covers science. It's in the science section. And it's called A Landmark Study on the Origins of Alcoholism. By studying rats in a smarter way, scientists are finally learning something useful about why some drinkers become addicted and others don't. That is fascinating. That's also going to piss off some of the more ideological members of AA. And I'm okay with that. Before I delve into the article any further, I want to reiterate for some of you or tell some of you about some of my theories based almost entirely on anecdotal evidence and from myself being in psychotherapy and with psychiatrists, as well as in the rooms of AA for a long time. You will often hear people in the rooms of AA especially, but in NA too, say that there is a solid reason for the two fellowships to be separate. I agree and disagree. Anecdotal evidence has suggested that there is a difference in the addiction itself, that drug addiction of almost any kind and alcoholism in the long run look quite different. The alcoholic may begin an alcoholic and find drugs later and become a drug addict. And then stop using drugs, get clean, so to speak, but continue drinking and drinking alcoholically, which more often than not leads back to drugs because as I'm sure you've heard people say, at the bottom of every glass is your dealer's number. The disinhibitor makes it seem okay to buy drugs again. That would be true, I think, for any drug addict who drinks after he or she gets clean, right? So even if he or she doesn't drink alcoholically, 1 or 2 drinks would have enough of a disinhibiting effect for the drug addict to want to buy drugs again more, and he or she would then have less of a defense against them. Many people in the rooms believe, and I agree, that a drug addict is not necessarily an alcoholic. And while to some degree addiction is addiction, that mostly it needs treatment by complete abstinence. So to some degree, addiction is addiction. And to some degree, the big book of Alcoholics Anonymous and AA can help anyone, at least in the beginning. There is something noticeably different about the trajectory of an alcoholic story as compared to the trajectory of a drug addict story. My theory has always been that the alcoholic addiction is chemically somehow, genetically different from the drug addiction. Whatever the drug addiction is, it is altering in a different way, and the alcoholic is processing alcohol differently. There's a different mechanism of action for alcohol than there is for drugs. In essence, I'm saying that the opiate addiction is more dangerous because the addiction itself is more available. That is to say, anybody can be addicted to opiates. And while in some ways I think alcohol is one of the most destructive addictions, I think it is a lot less likely that people will become addicted to alcohol. This is one of my arguments, however, for being more open-minded at AA. And you will hear the opposite argument, which is a compelling one, that these fellowships stay very separate from one another because there is such a difference. But especially with the plague of opiate addiction, I think it is even more important to find a way to be as inclusive as possible. Again, this is all my experience. These aren't facts. I'm not pulling numbers out of anywhere. I'm not using any data or studies. This is just based on my experience. I'm going to start reading it now. For Marcus Heilig, the years of dead ends were starting to grate. A seasoned psychiatrist, Heilig joined the National Institutes of Health in 2004 with grand ambitions of finding new ways to treat addiction and alcoholism. Quote, "It was the age of the neuroscience revolution, and all this new tech gave us many ways of manipulating animal brains," he recalls. By studying addictive behavior in laboratory rats and mice, he would pinpoint crucial genes, molecules, and brain regions that could be targeted to curtail the equivalent behaviors in people. I'm going to pause here for a minute to say I am not a fan of animal testing. I am not a proponent of animal testing. I donate money to organizations like PETA and the Humane Society. And I'm a little bit of a hypocrite because I appreciate often, as many of us do, knowingly or unknowingly, the results of a lot of the studies done using animals. Would that it were black and white. To continue. It wasn't to be. The insights from rodent studies repeatedly proved to be irrelevant. Many researchers and pharmaceutical companies became disillusioned. Quote, we cured alcoholism in every rat we ever tried, says Heilig. And at the end of every paper we wrote, this will lead to an exciting treatment. But everything we took from these animal models to the clinic failed. We needed to go back to the drawing board. Heilig doesn't buy that mice and rats have nothing to teach us about addiction. It's more that researchers have been studying them in the wrong way. Typically, they'll let the animals self-administer drugs by pressing a lever, which they almost always learn to do. That should have been a red flag. When humans regularly drink alcohol, only 15% become dependent on the stuff. Why them and not the other 85%? That's the crucial question, and you won't answer it with an experiment in which every rodent becomes addicted. I would pull back just to say that 15% may be on the low end because there are so many people who still stigmatize it or who have a drinking problem, but because their lives are manageable and haven't been affected in the classic ways alcoholism affects people, may not report the incident. So, the number is probably greater than 15%, but even if we say 25% of drinkers, even if you were to say 50% of drinkers, why, and that's clearly too high, but why not the other 50%? Eric Augier, who recently joined Heilig's team, tried a different approach, one pioneered in his former laboratory to study cocaine addiction. After training rats to self-administer alcohol, he offered them some sugary water too. This better mimics real life, in which drugs exist simultaneously with other pleasurable substances. Given a choice between booze and nectar, most rats chose the latter. That means they chose the nectar. But not all of them. Of the 32 rats that Augier first tested, 4 ignored the sugar and kept on shooting themselves up with alcohol. 4 rats is laughable, says Heilig, referring to the study's small size. But 620 rats later, no one's laughing. Augier repeated the experiment with more rats of various breeds and always got the same results. Consistently, 15% of them choose alcohol over sugar, the same number as the proportion of human drinkers who progress to alcoholism. Those alcohol-preferring rats showed other hallmarks of human addiction, too. They spend more effort to get a sip of alcohol than their sugar-preferring peers, and they kept on drinking even when their booze supply was spiked with an intensely bitter chemical or paired with an electric shock. That's pretty incredible. So 15% of them would go to any lengths to drink. The other 85% preferred the sugar water, preferred the nectar. They opted for that. That was striking to me as a clinician, says Heilig. Embedded in the criteria for diagnosing alcoholism is that people continue to take drugs despite good knowledge of the fact that it will harm or kill them. Many lab studies treat animals as if they were identical, and any variation in their behavior is just unhelpful noise. But in Augier's work, the variation is the important bit. It's what points to the interesting underlying biology. Quote, "This is a really good study," says Michael Taffy, a neuroscientist at the Scripps Research Institute who studies drug addiction. "Since only a minority of humans experience a transition to addiction, an approach such as this is most likely to identify the specific genetic variants that convey risk." That is exactly what the team did next. They compared the alcohol-preferring and the sugar-preferring rats and looked for differences in the genes that were active in their brains. They focused on 6 regions that are thought to be involved in addiction and found no differences in 5. But in the 6th, we did, says Heilich, and it made me smile because I started out doing my PhD on the amygdala. The amygdala is an almost almond-shaped region that sits deep within the brain and is heavily involved in processing emotions. When Augier looked at the amygdala of an alcoholic rat, he found signs of unusually low activity in several genes, all of which are linked to a chemical called GABA. GABA, we'll call it GABA, is a molecular red light. Certain neurons make and release it to stop their neighbors from firing. Once that's done, the GABA-making neurons use an enzyme called GAT3, to pump the molecule back into themselves so they can reuse it. But in the amygdala of alcohol-preferring rats, the gene that makes GAT3 is much less active and makes just half the usual levels of the pump. GABA accumulates around the neighboring neurons, making them abnormally inactive. Well, I'll be. So the anecdotal evidence of many people in the rooms of AA and who have struggled with addiction in general is being proven to a degree in neuroscience. To read the rest of the article, visit theatlantic.com. Thanks so much for listening, and I hope this has helped you to feel like no matter what, there is a way.